Hello everyone. Today I'm going to show you how to use our data to create a dataset for TensorFlow.js, and we are going to do that using tf.data package, which is part of the TensorFlow JavaScript package that we are generally using. As you can see, that TensorFlow.js data provides a simple API to load and parse data from disk or over the web in different formats, so you think like CSVs, JSONs, whatever. And the nice thing about the data API is that it allows you to actually wrangle or transform your data however you want. There are a number of utility functions that we are going to use together now, and that are going to be added even down the road, since this package is analog to the tf.data Python package, which is like pretty huge, and it allows you to do pretty much whatever you want with your data as of pretty much today. Okay, so the first thing that you might want to have a look at is the simple example that is provided within the GitHub repo, and it shows you how to read CSV file from the web, pretty much what we are doing here, and then create a dataset from that. But I'm going to walk you through our example using tf.js data, and the API is available on the TensorFlow website. The API shows you how you can create a data from an array, CSV, or generator function, or directly from a webcam. And here are the operations that you can use to create to manipulate your datasets once they're created. So the first thing that I'm going to show you right now is actually how to install TensorFlow.js on our local machine. I'm continuing with the project that we've left the last time, and here is the last chart that we've actually shown. It's the skin thickness versus BMI for the patients, and I'm going to comment out this one, or I'm going to delete it altogether, refresh that, and I'm going to actually install the tf.js by copying and pasting the command from the site. Okay, this is going to install pretty much every package, including tf.js data, as you can see. Okay, so I'm going to start the app again. And the first thing that I'm going to do during this time is to import the tf.js library, and I'm going to do that on top of this. From TensorFlow tf.js, and the next thing that I'm going to do is actually define a function which we will call create datasets, which will take a couple of parameters. It's going to take the data or the CSV file that we've already loaded. Then it's going to take the name of the columns or the features that we're going to use. The next thing that this function will take as a parameter is a parameter called test size, and this will control how much of the data what proportion of the data we're going to use for training and testing our model once it is created. And the last parameter is the batch size. The batch size parameter is a bit tricky. I mean, like, it's not really intuitive to understand what the batch size means, but after we go to the training part of the app of the model, I'm going to show you how batch size is going to be used. But then again, right now we are just interested in creating our datasets using the data API. Okay, So the first thing that I'm going to do is extract the features or the x values that we're going to use for our dataset. And to do that, I'm going to create a constant called x. And this one is going to be the features that we're going to use for this one will only include the features that we are going to use for the training our models. And then I'm going to create another constant called y, which will contain the labels or the true values. In our case, that means if our patient is diabetic or not. And here I'm going to take each row, and for each row I'm going to take the features that we are passing as names. Once again, the features that we have in here, I'm going to show you. Our data has the following features. If we print them out, okay, we have age, BMI, blood pressure, diabetes pedigree function, glucose, insulin, pregnancies, and skin thickness. And again, outcome is whether or not, okay, the outcome is whether or not a patient has diabetes or not. So this will be our label. This will be only available for our y values, and all of the other ones we can use for training our model. So they will be in our x values. Okay, so for each feature, I'm going to do a check if the value of that feature, for that feature, if the value of that feature is undefined. If the value is undefined, our training using TensorFlow.js will most probably fail because frankly, TensorFlow.js can't handle, at least for now, can't handle undefined values. So TensorFlow.js expects from you to provide only numerical values. So what we're going to do is actually check if the value is undefined, and if it is undefined, we're going to impute it or replace it with a value that we think that might be somewhat okay to be replaced with. And unfortunately, the data imputation part of our tutorial is going to be like really dumb. We're going to just put as zeros. Remember that 0 was the value that we've observed in our charts when there were probably no real value for the skin thickness, for example, for the triceps measurements. So we're going to do the same dumb thing here, and you can expect that your model is going to be a little bit buggy because we're inputting like garbage data in, and the predictions might not be as good as you might want. But for the purposes of this tutorial, I'm going to do this dumb thing, while in a real world application I would probably have a look at some imputation methods. Particularly on my blog there is one that is that provides an example of how to use autoencoders for data imputation, and maybe I'm going to port that tutorial to TensorFlow.js and show you how to do that later in the series. Okay, so enough talk, let me just check if the value is undefined, and if it is undefined I'm going to put 0 as we've already talked about, or else I'm going to return the value. So now we have the x values for the feature values for our model, and we're going to do kind of similar thing for the y values. Again, the y values are the labels or the outcomes for our patients. So here I'm going to create a constant called outcome, and again I'm going to, let me just check the row. And again, I'm going to check if the outcome is undefined. I'm going to return 0, otherwise I'm going to return the outcome. And the interesting thing in here is that I'm not going to return directly the outcome, but I'm going to call a function called OneHot. Excuse me. Sorry about that one. Okay, so we're calling actually a function called OneHot, which we haven't created yet, and I'm going to do that just now. Okay, so I'm going to define that, and this function is going to take a single parameter called outcome, and we're actually going to use TensorFlow in here. So the thing that I'm going to use is tf.OneHot. Let me check if my import is missing. And it is. Okay, so now I'm using OneHot. And I'm going to pass in the outcome. And I'm going to specify a second parameter 2. Then I'm going to call the datasync method, and this is going to return an array. Let me just do that. And this is going to return an array that is actually OneHook representation of the data. What does OneHook actually does, or what does it do? Okay, I'm gonna show you. Okay, so let's have a look at an example of what OneHook does. But no, maybe I'll just run it in my run function in here. That way it might be easier for us to get a feeling of what's going on. So let me call OneHook in here. And I'm going to pass in a tensor, which will have a value of like maybe 1. So remember that our outcome of 1 means that the person has diabetes, and if it's a 0, it means that it is healthy person. So I'm going to pass in 1, and the second parameter in here represents the depth of the OneHook dimension. So what this means is, like, if I pass in 2, I expect to receive a vector which is of size 2. It has 2 values in it, and the values are going to be 0 and 1. Let me just run that for you. Okay, so let me do that. So I'm doing something wrong in here. Oh, okay. I don't have to input a tensor in here. So let me do just that. And yeah, here we go. We have a, let me try this one. Okay, so that's better. So here we have a tensor representation of our OneHook encoding. And if I put in 0, I'm expecting our vector to be 1, 0. So this pretty much puts 1 where the value should be in this array, in this index, and all other places we have zeros. So that's pretty much it. And if I put in here like something like 5, I'm going to be I expect to have a vector of 1 and 4 zeros after that. So let me try this one. So you might get a general feeling of what's going on. Okay, so this seems to be working for now. Okay, let's continue with our create dataset function. Let me find it out. Okay, here we go. Okay, so now that we have our x's and y's, we can actually use the next parameter, which is called test size, and the test size is going to be the place or the fraction of the data that is going to be used for testing and for training and validation. So I'm going to calculate an index at which we're going to split our data. Remember that our data is just a simple array, so we can use an index to split it. And I'm going to calculate the size of the data, which is going to be 1 minus the test size. The test size can be actually the possible values for the test size are fractions that are between 0.001 to something like this, or maybe even, yeah, you can actually input something like this too, but it must be a floating point value. So if I want to have a test size of 10%, I'm going to call this function with create datasets. Let me call the function actually for you. Okay, the features I'm going to use for now are just BMI, for example, and the test size I'm going to pass in is going to be 10% or 0.1, and then for the batch size I'm going to specify 16, and I expect this function to return training dataset and validation dataset. Okay, so let me just come here and finish the split index calculation. Okay, so if I calculate the amount or the fraction of the training data, which is 1 minus the fraction of the test size, I'm going to multiply that by the length of the data, and I'm going to specify that for the parsed int function, the radix or the base of the number is in base 10. Okay, so the last thing not the last thing, but another thing I'm going to do is actually finally use the tf.data, and using the zip function, I'm going to pass in the x's, or these are the features that we're going to use for our training, and I'm going to create those from the array x, and for the y's I'm going to do the same thing, just using the y. Okay, and I'm going to actually shuffle the data with a seed number of 42, because yeah, you know why we're using 42 as a seed number. It's not even a special constant or something like that. Everybody should know what this is. Okay, so the first parameter in here is something known as buffer size, which is rather badly explained. Let me go to the data, shuffle, and shuffle. Okay, so they say that the buffer size is an integer specifying the number of elements from the dataset for which the new dataset will sample. And I literally have no idea what this means. So if you know what this is, or how should one use it, please tell me in the comments below. I'll appreciate that. Okay, for now I'm just passing the length of the data. So actually the buffer is going to be the full data. I hope that this works. Okay, so the last thing that I'm going to do is split this dataset into a training dataset by taking the first amount of data that is provided by the split index, and I'm going to, if I click that, and I'm going to show you that the take just takes the first n values of the dataset. Okay, and on that I'm going to call the batch method, and I'm going to pass in the batch size parameter that we are passing from above. Again, the batch size is going to be the amount of training data, in our case 16, that is going to be passed during the training to our model at a time. So we have a batch size of 16, so our model is going to be seeing 16 training examples, and then another 16, then another 16, etc. Okay, so for the validation data set, I'm going to skip the first split index numbers, and I'm going to pass in 1. And again, I'm going to split that into a batch size. Okay, so to check if everything is working, I'm going to wait for this to happen, to complete compiling, and then I'm going to actually take, let me see. Okay, I'll take the first like 10 values of the training vals. I'm going to take from the training dataset the first 10 values, and then I'm going to like do just that, which is going to print each value, and I'm going to wait and see. Okay, so yes, we have 10 examples from our training data, and as you can see, each example has an object which has two properties: axis, which is a tensor with a shape of 16:1, because we have a batch size of 16, and then and 1 for that, it is just because we have a single feature that we've specified, it's BMI for now, and we have y's, and the y's must be in 16:2, because remember that we one-hot encoded them into arrays of two values with two values. So this is pretty much it for this video. In the next one, I'm going to show you how to use this dataset to train a really simple model in TensorFlow.js, and hopefully we will have a good enough model that can predict pretty well if a person has diabetes or not. Thanks.